Hello friends, this video on equilibrium part 15 is brought to you by examfear.com. No more fear from exam. Before watching the video, please make sure that you have watched all the previous parts. Let's take one more example. So the question says at 700 Kelvin, the equilibrium constant for this reaction is 5.48. The reaction is this. Let me write the reaction. H2 plus I2 all gas gives 2HI. A 0.5 mole per liter of HI is present in equilibrium. That means I'll write here T is T is equal to equilibrium and this is T is equal to 0. T is equal to equilibrium, this value is what? 0.5 moles per liter. So it's 0.5 m, right? Moles per liter. What is the concentration of H2 and I2 assuming that we initially started with HI? That means it's saying that we started with HI with some number. Let's suppose we started with n moles of HI and 0 moles of H2 and I2. After a certain time, let's suppose this becomes n minus x, this becomes x, and this becomes x. Okay, that's what we can do. So you start with n moles, this becomes n minus x, and you create, this becomes n minus 2x. If you take 2 moles of x, the next moles will be created. Why? Because it is 2HI. Correct? But n minus 2x is 0.5 given. And the whole value of K is also given. So K is what? Concentration of HI square by concentration of H2, concentration of I2. Correct? HI square, I2 and H2. What is the concentration of HI? 0.5 m square. Concentration of H2 and I2 are both x moles per liter and into x moles per liter. You solve the value of x because this is nothing but 54.8 Kc is given is nothing but 0.5 into 5, that is 0.25 m square by x square. So you solve this, you get x is nothing but 0.068 m, that is 0.068 moles per liter. That means the equilibrium concentration of H2 is what? 0.068 m, that is moles per liter, and for I2 is also what? X, that is nothing but 0.068. That is the answer. Easy one. See, you started with some n moles of HI, so 2x is used and it created x and x moles of H and I, but this whole thing is 0.5 m moles per liter. So we just use the formula to get the value of x, and that is what the concentration of hydrogen and iodine. Let's take one more question. What is the equilibrium constant for each of the substance in the equilibrium when the initial concentration of ICl was 0.78 m? And the reaction is given 2 ICl gives I2 plus Cl2, iodine and chlorine gas, and Kc is 0.14. So we have to find the equilibrium concentration for each of this thing, where at T is equal to 0 it is given that ICl was 0.78 mole, this was 0 and this was 0. At T is equal to equilibrium, let's assume this becomes 0.78 minus x, this becomes, let's suppose this is 0.78 minus 2x because this is 2 ICl. So this is 0.78 minus 2x, this becomes x, this becomes x. So my Kc will come out with what? Concentration of iodine, concentration of chlorine, and concentration of ICl to the power 2. So what is the concentration of I2? It is x moles per liter, and concentration of chlorine x moles per liter divided by concentration of chlorine, that is ICl, that is 0.78 minus 2x moles per liter to the power 2. Right? And this value is nothing but 0.14. 0.1. So this is nothing but x square by 0.78 minus 2x. There won't be any unit here because these are moles per liter. So 2 moles per liter and this is also moles per liter, these are all divided and there will not be any unit. So you solve this, you get x is nothing but 0.17 m. That will be the unit of x. Correct? See, because 0.7 0.8, this is m. So x unit is also m. So this is 0.17 m is the value of x. So the concentration of I2 is what? X, that is 0.17 m. Concentration of Cl2 is what? X, that is 0.17 m. Concentration of ICl is what? 0.78 minus 2x, that is 0.17. You solve this, it is 0.44, and that is my x. Let's take one more example. The Kp is 0.04 atm at almost 900 Kelvin. What is the equilibrium concentration of C2H6 when it's placed in the flask is 4 atm and allowed to come to equilibrium? That means it says that you have this at t is equal to 0, you have kept some 4 atm pressure was there for this, and there is no pressure from this because it doesn't exist. And t is equal to equilibrium, what happened was some P pressure was reduced from C2H6 and P pressure came here and P pressure came here also, right? Because the reaction happened, C2H6 decomposed into C2H4 and H2. Now it says that Kp is given that 0.04. So what is the Kp value? Kp value will be C2H4 concentration or pressure of C2H4 into pressure of H2 by pressure of C2H6. Correct? So what is this? This will be P into P by 4 minus P, and this value is given as 0.04. So if you solve this, P comes out to be 0.40. So if my P is 0.40, I have everything now. I have the pressure of H2, what? 0.4 atm. I have the pressure of C2H4, 0.4 atm. I have the pressure of C2H6, that is 4 minus P. This 4 minus 0.4, that is 3.6 atm, and that is my answer. Correct? So the question asked me only the pressure of partial pressure of C2H6, but I found the partial pressure of all these. A sample of PCl5 was introduced in a evacuated vehicle at 473 Kelvin. After equilibrium was attained, the concentration of PCl5 was found to be this moles per liter. If the value of Kc is this, what are the concentration of PCl3 and PCl2 at equilibrium? So it says that at equilibrium, I don't know at t is equal to 0, but at equilibrium, this value was, let's suppose at t is equal to 0. T is equal to 0, some m moles were there and 0 moles of PCl3 and Cl3 was there. C2. At t is equal to equilibrium, this will become m minus x, let's suppose, and this becomes x, this becomes x. And this m minus x is nothing but given as 0.5 into 10 to the power minus 1 moles per liter. So my Kc is what? Concentration of PCl3, concentration of Cl2, concentration of PCl5. What is the concentration of PCl3? X, Cl2, x, and PCl5, 0.5 into 10 to the power minus 1. And this value is given to be, Kc is 8.3 into 10 to the power minus 3. So you solve it to get x is equal to 2 into 10 to the power minus 2. What will be the units? It will be m, because everything is m here, moles per liter, right? Moles per liter, right? This is the value of x. So we have to find the concentration of PCl3 and Cl2. So concentration of PCl3 at equilibrium is what? X only, right? This is nothing but 2 into 10 to the power minus 2 m. Similarly, concentration of Cl2 is what? At equilibrium, x. That is nothing but 2 into 10 to the power minus 2. Easy one. See, just have to assume that at t is equal to 0, it had some values. T is equal to equilibrium, it will, some x will be decomposed to create x and x of Cl3 and Cl2, and then you can just solve to get the value of x. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.